All right. Similarity, we've decided that it means kind of the same, almost the same. And the last definition was thrown out by Keeley. It's a different size, but the same shape. Now, right now, what I'm going to do is ask you to just look at the two pictures and tell me if you think that they're different size but the same shape. And then later, the next thing I'm going to show you is exactly mathematically how to check whether or not they are the different size and the same shape. Does that sound all right with you? Because right now, I'm asking you to just trust what the pictures look like. But in real math, don't ever trust what the picture looks like, especially when you're taking a test and you just be like, oh, that looks like it's about the same. Yeah, but unless you have a ruler and a protractor on you, you can't say exactly, oh, those are the same. So let me show you what I'm talking about here. Let's talk about this one. First of all, are these congruent? Top left. No, they're not congruent. They're not. They're absolutely not the same exact figure. Are they similar though? No. Why not? They're kind of the same shape-ish, right? This one's a triangle. That's a triangle. Triangle's a shape. Yeah, but it's not similar enough in terms of it's almost like anyone ever used like some kind of just any program. Here, watch. If I were to use like, let's see. Oh no, I don't want an image. I want a shape. All right, let's make any shape. Triangle. Triangle looks good. Okay. It's almost like if I were to copy and paste that. All right. Copy and paste. Control C, Control V. That is congruent. These two triangles, absolutely congruent. Agreed? I didn't change them. I moved it around, but it's the same triangle. I just copied and pasted it. Now, if I were to move this around like this, well, yes, they're both triangles, but they're not similar actually because they don't have the right, what we call proportions. What I would have need to have done is actually move this around, but hold the shift key down. Have you ever done that? And now what that does is if you try it pretty much in any program you work in. Move the corner and hold the shift key down. All of the programs do this. And what it does is it makes it the exact same kind of triangle, just like, you know, these triangles, would you say that they're similar to each other? But the thing is, so all the proportions remain the same, but the thing is, the size is different. So you're just making it bigger, but you're not making it distorted. You see what I mean? All right. Let's do this one. Is this congruent? Are these two circles congruent on the top right? Yes, absolutely. So are they similar? Well, yeah, they're similar because they have the same shape, but you know, they're also congruent, so why are you bothering with it? Now this one right here, is this one congruent? Are these congruent? No. But are they the same? Are they similar to each other? Ah, now you folks are definitely saying, okay, this one on the bottom left is definitely similar to each other, whereas this one on the top left, you folks said is not similar to each other. Now, I understand that these are both T's, and I see where you folks are getting at. I'm going to make sure that I'm going to make sure that we know the mathematical reason why they're similar in just a second, but I agree with you with your ideas, with your preliminary thoughts. Okay, and then the last, bottom right, is this congruent? Yes. Yes, yes, yes. Okay, let's see. Our answers are no and no. Oh, we got that right. Yes and yes. Yes, good. Okay, not congruent, similar. Good. And yes and yes. Okay, cool. So you folks got the hang of this without me even really teaching you anything.